impulse and impact is different. Impulse is just mathematically the force multiplied by the time of duration of the force is acting on this particle of interest. And that induces change of momentum. Suppose you have two small ball that can be considered as a particle. And that is moving in this direction. And this one is moving that direction. Say this is V1A, and this is V1B, and this is MA, and this is MB. And it will collide. And what's going to happen? When it collides, there will be a force acting on this particle due to particle A, and there will be a force acting on this particle due to particle B. In that case, what is the impulse in this system? When this one is hitting each other, what is the FDT in this case? There are two forces. One is this direction, and the other one is this direction. And displacement is the same. What is it? What is the impulse? Resulting impulse. And I hit this guy. What is the resulting impulse? F dt. What is the resulting impulse? You need this impulse, right? No? What is the resulting impulse? Okay, let's draw a free body diagram when it hit. Cut it. There's a force acting this direction, and there's a force acting that direction. Because the third law, Newton's third law, that force is the same, but different direction, opposite direction, and the same time. Therefore, that is the resulting impulse is 0. Therefore, this one is 0. Therefore, L1 is equal to L2, and we call this case as the case of which linear momentum is conserved, because impulse is 0. All right? So that means many interesting things. Okay, you have a bat, baseball bat. Okay. You have a ball coming this direction with the speed of V1. And then you are hitting the ball with some force and some duration of time, delta t, right? And using principle of impulse and momentum, you can say F delta t is equal to what? Linear momentum at time at state 2 minus linear momentum at state 1. And say this is a state 1. Just before I hit the ball. And state 2 is just after I hit the ball. Then I say L2 is m V2, and I'm using coordinate this as the coordinate, minus mv1 is equal to the force multiplied by delta t. So if F is very large, then I can produce big difference. That means V2 can be increased, right? Therefore, when you make a big hit, the force has to be large, right? But if you want to exert a larger force, there is another factor. Because you are exerting larger force, you may lose your control to hit the ball. So it's not always nice to have very large force, because producing very large force may produce some motion that is not possible to produce a big hit. But one very clever student may say, instead of increasing F, I want to increase delta T. How can we do that? Maybe I put a sponge on a bat that will introduce delta T. Then there is a lot of possibility to have a large momentum change. Why not? Right. So he said we have to increase delta T. We have to follow the ball as far as we can. That will increase the delta T that produce larger momentum change. Okay. So it is an interesting principle. And this principle has the property that handles force and the time and velocity. Okay? Recall that another principle, Newton's second law, involves force, acceleration. And another principle, energy principle, involves force, displacement, and velocity. There are 3 different tools. And those tools has different property. So depending on your interest, you have to select the tools by yourself. That's very important. After you select the tools, then you have to implement your tool according to the rule that the rule insists to follow. For example, using Newton's second law, what is your first step? You have to find out force first. And then you have to express the acceleration. To express acceleration is vector. Therefore, you have to select a coordinate for your convenience. And then you write down your Newton's second law graphically, draw Newton's second law graphically, and then write down the equation of motion, and the count number of unknowns and the number of equations. And if number of unknowns is larger than number of equations, that means you have to find out conditional constraint. They can provide additional equation, so on and so on. And we learned about work done. And the work done is simply mathematically F vector dot product displaced vector dr. How to apply principle of work done? You have to find, of course, first all the forces. And you have to define dr vector. To define dr vector, you have to employ, again, coordinate. Okay? And that induces change of kinetic energy. When the forces are conservative ones, then work done induce change of potential energy. Is it correct? Change of potential energy normally means that V2 minus V1. But in this case, V1 minus V2. Okay? And again, you have to be very careful to use the coordinate to find out correct potential energy. That summarized today's lecture. And I hope you work with example that is introduced in the text. Okay? Next lecture, we will talk about principle of impulse and momentum again, and then we will talk about coefficient of restitution, plastic impact, elastic impact, and so on. Okay.